Without positive train control, a high-speed train can derail in seconds, and no one can stop it. Imagine a sleek Amtrak Acela Express traveling over 150 miles per hour, careening through a curve completely out of control. Today, we'll uncover the one system that keeps millions of passengers safe every year, and how its failure can turn a modern marvel into disaster. Positive Train Control, or PTC, is the brain of modern rail safety in the USA, installed in high-speed passenger trains like the Amtrak Acela Express and in freight systems across the country. PTC is designed to prevent the most common causes of train accidents: overspeed derailments, collisions, and human error. But how exactly does it work? At its core, PTC is an integrated computer system connected to sensors along the tracks and inside the train. It constantly monitors the train speed, the curvature of upcoming tracks, the location of other trains, and the braking distance required to safely navigate every segment of the journey. Every second, the system calculates momentum, centrifugal force, and tilt to determine whether the train is operating safely. If the train approaches a curve too fast, the system calculates the lateral forces that would push the train outward. Wheels could lose grip, tipping the train off balance. If the operator doesn't reduce speed, PTC automatically applies the brakes, engaging both dynamic and friction brakes to bring the train safely within the required speed range. This system also communicates continuously with trackside sensors. Each track segment has embedded transponders, sending data to the onboard computer: track conditions, signal states, upcoming speed limits. The PTC calculates braking curves based on real-time physics, mass, velocity, track geometry, and train length. Every decision is made within milliseconds, faster than human reflexes. From a physics perspective, trains generate enormous kinetic energy due to their mass and velocity. On a high-speed curve, centrifugal force pushes outward. The train's center of gravity becomes critical. Without countermeasures, these forces can lift the wheels off the track, causing derailment. PTC works together with the gyroscopic stabilizer to adjust tilt angles and braking to keep the train centered, distributing forces safely across all wheels. PTC is like a digital conductor, constantly predicting dangers, correcting speed, and balancing forces that human operators cannot respond to at 150 miles per hour. Without it, the most minor miscalculation becomes catastrophic. Each brake cylinder, traction motor, and tilt mechanism communicates through the onboard network. Sensors monitor wheel rotation, track curvature, and train load. The system continuously computes braking force for each wheel individually. If one wheel begins to slip, adjustments are made instantly, maintaining stability. Now imagine the same high-speed train, but without PTC. The operator misses a speed restriction. The train enters a curve too fast. Without automatic braking, kinetic energy pushes the train outward. Centrifugal forces lift the wheels off the rails, tilting the train. Within seconds, the entire car derails. A disaster that is preventable becomes inevitable. This is not just theory. On May 12, 2015, the Amtrak Northeast Regional Train, number 188, traveling from Washington, D.C. to New York City, derailed in Philadelphia, Pennsylvania. The train entered a curve at over 100 miles per hour, far exceeding the speed limit. Investigations revealed that PTC was not yet active on this track segment. 8 people lost their lives. Over 200 were injured. The train cars were heavily damaged. This disaster underscores why PTC is mandatory today, saving lives by preventing human error from becoming catastrophe. Every time you board a high-speed train in the United States, remember, it's not just steel and wheels keeping you safe. It's a network of sensors, computers, and automatic controls, working silently, millisecond by millisecond, to make sure a tiny mechanical system never fails. Because if it does, the consequences are unimaginable.